All right, so we're gonna start with a quick revision. Everybody can hear me?
Yes, sir.
All right, good. Everybody can see the screen as well. Everybody can see the screen. Can you all see the screen?
Yes, sir.
Yes,
All
sir.
right, good. All right, so we're gonna start with a quick revision, basically by going back over this classwork that we did. All right, just to go through it one more time, and then we're moving on today to how we find the roots. That's what we're gonna look at today. How can we find the roots? We're also gonna take the opportunity to do some factorization, right? Because factorization is one of the methods that we're gonna be using to find the roots. And so since we're doing factorization, from that perspective, we'll just do factorization in general, which is just like the last slide, something quick and easy. All right. So this question, classwork, they gave us that function g of x, and they can call it anything they want. They can call it y, f of x, g of x, doesn't matter, h of x, same thing. Sometimes they don't call it anything, they just write the expression. First part wants you to write it in the form a into x plus h r squared plus k. And in this example, they want us to state the value for a, 8, and k. All right, so let's go. So starting by saying the g of x is equal to 3x squared minus 8x plus 2. And we know we're going to need the a, the b, and the c, so it makes sense to just write them down from now. So the a is 3, which is the coefficient of the x squared is 3. And the b is the coefficient of the x, which is the negative 8. So the b is negative 8. And the c is a constant term, which is 2. All right. And they want us to write it in the vertex form. They want us to write it in this form, which is a into x plus h squared plus k. That is to complete the square. But our method is to write it as a into x minus, even though they have a plus, we are using a minus xt. Xt is x value at the turning point squared plus yt. Yt is the y value at the turning point. So we're going to be using this. So our objective is to find the value of xt and the value of yt. Because we know the a value already is 3. All right. So the xt is equal to negative b divided by 2 times a. That's a formula for xt, which you must know. Which then would be equal to minus, that is this minus that I've placed there first. And then the b now, the b is negative 8. So it's minus and negative 8. You can bracket it, or you can leave it like that, doesn't matter. It's going to become a plus 8 anyway, divided by 2 times 3. So basically it becomes a positive 8 over 6. And the 8 and the 6 can each be divided by 2, so we can simplify it down and write it instead in lowest terms as 4 over 3. And it's a habit that you must have to write your expressions in lowest terms. All right, and then the yt now, formula is 4ac minus b squared divided by 4a. And put the values in now for a, b, and c. It is 4 times the a, which is 3, times the c, which is 2, minus, that's this minus, which is not squaring, and the b is negative 8. So it's a negative 8 squared, and dividing that by 4 times 3. 4 times 3. And when you work the value on the yt comes 4 times 3 is 12, and 3 times 2 is 24, minus that minus coming back here because it's not squaring. And the negative 8 squared is 64. So this now is the 64. Right? And you divide that by 4 times 3 is 12. All right, that simplifies to negative 40 over 12. 24 minus 64 is negative 40. Again, this can be divided by 4. This can be divided by 4 and this can be divided by 4. So if each of them by 4, you get negative 10 over 3. And that's the lowest terms. So now that we know the xt value and the yt value, the xt value is, and the yt value is this. Those are values that we're going to put here and here. All right, and so this expression now becomes g of x equals the a, which is 3, bracket x minus xt value is 4, 3. Don't forget square, and the yt value is negative over 3. So the p is negative 3. And that's it. But the question now the value and k. So because I want to set the value for e, h, and k, we're gonna compare this thing with a into x plus h squared plus k. So we can write value for a, h, and k. We're gonna compare those two things. All right. We'll do the comparison. You see that the a is 3. That's easy. The a is equal to 3. The plus h is minus 4 over 3. So the plus h is minus 4 over 3. Or we need to put the plus. We can erase the plus. And compare again the plus k is minus 10 over 3. So the plus k is minus 10 over 3. And again, we don't need to put the plus. So those are the values a, h, and k. So basically that's the answer for part 1. We have completed the square, write it in the vertex form. That's this. That's this right. And we have given the value of a, e, and k. So those are your answers right there. That's part 1. Part 2 wants us to state whether it has a maximum or minimum. Part 2. So we can say since the a, which is equal to 3, is a positive value, g of x has, but when it's a positive value, the graph will have a smile shape. And what has a smile shape, it has a minimum down there. So therefore, g of x has a minimum value. That's the first. Part 2. Part 3 says we are to state this maximum or minimum value. We know it's minimum, all right? We have to state it. So state here now the minimum value of g of x is the lowest y value on the graph, which is y value, y value turning point, is equal to the negative 10 over 3. They didn't ask us for the minimum point. Some persons were answering the minimum point. The minimum point is xt, yt. The values of xt, yt in the bracket, like coordinates of a point. This is asking us for the minimum value. Minimum value is the lowest y value on the graph. All right. Then part 4 is asking us to state the value of x at which g of x is maximum or minimum. We know it's minimum. So g of x is minimum at the point where x equals xt, because the xt and the yt are at the same point. All right, so let's write it. G of x is minimum minimum when is it minimum? It's minimum when the x value is equal to xt value at the point where x value is xt, which is the 4/3. Right? Xt up here was 4/3. Xt is 4/3. So it's when the xt value is 4/3. Right? 4/3. I can show you why it makes sense. If you look at this vertex form, right? When this x value becomes 4/3, this x becomes 4/3. Inside you get 4/3 minus 4/3. So all that work will be 0 when x is 4/3. And if that work out to be 0, then that is when the g of x becomes negative 10/3. So you see, the g of x is negative 10/3 when the x is 4/3. So the 3 is the xt value. Making other times. Alright. And that's it basically. Alright. Then we come to part 5, which is to sketch the graph. Alright, so part 5 is to sketch the graph. This is sketch. Sketch of g of x equals x squared minus 8x plus 2. Mute your mic, please. Mute your mic. Jesus. Mute your mic, please. All right. So that's a standard form. So remember now, in the standard form, we know the shape, the smile, because it is positive, and we know the y-axis intercept 0, C, which is therefore is C, which is 0, 2. And then the vertex form, which is g of x equals 3 into x minus 4/3 squared minus 2/3. This form tells us where the turning point is, the minimum point, a minimum turning point, which is xt, yt. And that minimum point is 4/3 minus 2/3. So this is what we need to do, is represent that information graph. So we have a smile shape graph that turns at 4/3, negative 10/3, and also crosses the y-axis at 2. All right. And I was listening back to the video, all right, and somebody asked a question. I didn't hear when they asked a question, so I can address it now. All right. So when we're sketching the graph, it is not scale. So you think that it has the right shape, which is a smile, that it turns in the correct quadrant. These are the quadrants: 1, 2, 3, 4. It's 4 quads. If I can number them, 1, 2, 3, 4. Those are the 4 quads. Right? So we want to ensure that it turns in the correct quadrant and this coordinate right here. Now, how do we know what point B? It has a positive x value, meaning it is to the right. Positive values are positive that in that direction. And it has a negative y value, which is down here. So the coordinates have a positive x value and a negative y value. That is why it is down here, turns down here. That's where that point would be. Right? That's how we know. So then class asked why that a point like that, for example, could be over here. Because over this side are negative x values. So for example, over here, a point would be, for example, -3, -6. On here, is negative x and negative y. What we want is positive x and negative y. That's why we want to turn it down there. So that was the answer for the question in the class that I missed when the person asked that question, but I heard it back in the video. The person asked why couldn't it be on the left side? Because left side values are negative, but one values are positive. All right, so that it turns, we know that it turns down here. The next thing is where will it cut the y-axis? Cut the y-axis at 0, 2, right there. 0, 2 is up here, so on part. So you must turn on here and cross the y-axis here. So we just need to sketch a smile that does that. All right, so any smile that does that, so I'm going to like, and that's it. That's a sketch. I know that point is going to be 0, 2. My y-axis intercept. I know that this is my minimum point coordinate to be 4, 3 minus 1 over 3. And then my axis of symmetry is a vertical line up here. And that equation is x equals the x value, which is 4. That is my axis of symmetry. Right? That's my axis of symmetry. That's my sketch. And then the question asks now to show the position of the roots, not the value, just the position. So the position of one root, so okay, call that root 1. That's the position of a second root 2. Root 2. And basically that was your classwork. Alright? That was the classwork. So we can just segue now and go straight into how do we find the roots. So taking it to the next level now, which is the purpose of the class today. How do we find those roots? So let's go straight into it. Now, if I want to find the x here and the x here, what information would I know? Let's just first write something. This curve is a curve g of x, or let's call it y. Y equals 3x squared minus 8x plus 2. That's the equation of that curve. In other words, all points on this curve, all points on the curve satisfy that equation. What do we know about the 2 points with the roots? Those 2 points are points on the x-axis. And points on the x-axis, what we know is that the y value equals 0. So this point is a point where the y value is equal to 0 because on the x-axis. Also, this point is a point where the y value is equal to 0. And you can see the y value is equal to 0. And you look at this function then, this function for the roots. You say the roots are where the roots occur where y value is equal to 0. That's where the roots occur. So if you look at this function now then, since the y value is equal to 0, and this is equal to y, right? Y is equal to the thing. And the y is equal to 0, and also the y is equal to this. And we see that the equation at those 2 points would become 3x squared minus 8x plus 2. That is the y. This is the y. And it is equal to 0 at those 2 points. That's what points. And therefore, this is called a quadratic equation. This now is a quadratic equation. Quadratic equation. Remember, this is a quadratic function. You know, this is the function. This up here is a function. This function. The quadratic, the Q function. This is function. The function gives you all the points on the graph. This down is a quadratic equation. You put it as 0, it's a quadratic equation. And therefore, to find the x value here and the x here, all you need to do is solve this quadratic equation. Solve this equation. When we solve that equation, we will get x value for here and the x value here. And essentially then, that is where you find the roots. Solve the equation. So see here, the quadratic equation. So we equation find the root. That's all we have to do. Solve that equation. And we'll find the roots for this curve. The two roots. You're going to two x values made of it. You're going to get one x value for here and a second x value for here. The small x will be for here and the large value will be for there. All right, and so the class now is about how do we solve this equation? What would we do to solve this equation? That is what this is all about. So basically, the summary is to find the roots, we solve the equation. Because remember, the roots are the points where the y value is 0. And if the y value is 0, then it means that we put the quadratic expression equals 0, meaning we are forming the quadratic equation. And when we solve the quadratic equation by whatever method, we're going to look at two methods to solve the quadratic equation. When we solve the quadratic equation, the x values that we get are the roots. The x values that we get when we solve the quadratic equation are the roots. So basically, if we want to find the roots, we have to solve the quadratic equation. Another way of saying it is when we solve a quadratic equation, we are actually finding roots. So when you solve a quadratic equation, you are finding roots. And if you want to find roots, you solve the quadratic equation. Remember, the quadratic equation is when you put the quadratic equals 0. You put the quadratic equals 0 because remember the y is equal to 0. All right, at the 2 points where the roots are. The y is equal to 0. So you put the y equals 0. Once you put the y equals 0, you end up with a quadratic equation. And the reason why this equation can be solved, the reason why it can be solved, because it only have one unknown in it, x. X is the only unknown in it. Any equation with one unknown can be solved. Any equation with only one unknown can be solved. The only unknown in that equation is x. Therefore, you can solve for x. It's just that you're going to get two possible values, two x values that will make this thing equal 0. One of the x value is here, and the x value is there. All right? So that's what this is all about, solving the quadratic equation to find the root. So we're not going to do this. We're going to go back now to the slide and see exactly what is what. So let's save this, and let's build on this now. All right? But understand so far? If you don't fully understand it, no problem. You'll get it as we go. But so far, so good? But good so far?
Yes, sir.
The answer, I know. I don't know. And by now, we're not in the classroom, I can see your faces constantly, you know. If I want to see your faces, I have to look at the, I have to put the video on and see who is there. All right, so we have to communicate to let me know that, you know, you're paying attention and stuff. Right? You have to do that. All right, so I'm asking if everybody okay so far.
Yes,
Everybody
sir.
say yes, no? Okay. All right, so that was the first part. Let's get into how we find the roots. So let's go to the PowerPoint now. Let's go to the PowerPoint. All right. All right, so solving the quadratic equation to find the roots. All right, so as I go, I'm gonna see if I can do a little thing over here. So let's go back again. So let's say I have a quadratic curve. All right, so we're at the PowerPoint and this thing over here simultaneous. So let's say I have a quadratic curve like that, and I have a curve. The quadratic curve is this. And let's say this quadratic curve is y equals ax squared plus bx plus c. Standard quadratic function. Our interest is in these 2 points today, the roots. That's our focus today, to find 2 roots. All right? Those are the roots. Those 2 points are the roots. All right? What we said before is that at this point, we know that the y equals 0. And at this point also, the y is equal to 0 because there are points on the x-axis. And if the y is equal to 0, It means that to find the roots, since y equals 0, then the expression ax squared plus bx plus c becomes equal to 0. That is what we're saying. So let's put on the PowerPoint over here now. Basically, what I'm gonna say now is basically what I've just shown on the graph there. All right. So solving the quadratic equation. When we solve the equation, we're solving it to find the roots. Axis. All right. So consider the graph of a quadratic function. As over here, on the graph, I put f of x, but I could have put y just the same, right? Consider the graph of the function f of x equals ax squared plus bx plus c. That's a graph that I've drawn on the right in blue, right? Representing all quadratic graphs. All right. The graph is obtained by plotting xy values for y equals ax squared plus bx plus c. Remember last week when we did a graph, we put a table and we calculate the points and we plot the graph. That's how we plot the graph. All right. To find where the graph cuts the x-axis, we have to put y equals 0 because we know that on the x-axis, the y value is always 0. On the x-axis, the y value is 0. And so if you want to find those points, you have to put what you know in the function. So you put what you know that the y is 0 in the function. And when you do that, you basically get that equation right there. All right? You get the equation right there. All right? And then that equation, that is the quadratic equation. And its solution gives the values of x, and there are usually two values that you get. Usually two values because there are usually 2 points. Usually 2 points. I'm going to show you some other possibilities just now. And it shows the values of x where the quadratic function, where the graph of the quadratic function cuts the x-axis. Those points are also called the x-axis intercept. All right. So when you solve the quadratic equation, you're getting the x values where the graph intersect the x-axis, cuts the x-axis. These values are called the roots of the quadratic equation. When you solve a quadratic equation, you're getting the roots. They're also sometimes called the roots of the quadratic function. Remember, the function is a full graph. The equation is just that equation that gives you the roots. All right? The equation that gives the roots is the one that is equal to 0. The function is basically the entire graph. So when you're talking about the entire graph, the roots are the points where the entire graph cut the x-axis, but they correspond to the roots of the equation, which are now the x values that you get when you solve the equation, right? And there's the x values at those same 2 points where the graph cut the x-axis, right? And these are the possibilities now. Let's look at some of the possibilities. All right, so what I've sketched on the right there is just one of the possibilities. So first, you can have 2 different roots. Possibility exists that you can have 2 different roots, as is the example here. If it's a smile, you can have 2 different roots right there. If it's a frown, again, you can have 2 different roots right there. 2 points of intersection. All right, you can have that. That's the first possibility. You have 2 different roots. All right, so there are 2 points of intersection. You can also have equal, or what we call repeated roots. That is when there's only 1 point. So when you see only 1 point on contact, what will happen there is that you have 2 equal roots. There's always 2 roots. A quadratic equation will always give you 2 roots. There can be 2 different roots, or there can be 2 equal roots. Now let me prove to you that you actually have 2 roots there. Oh Lord, excuse me for that. Let me prove to you that you actually have 2 equal roots there. Let me show you on this side. Or you really have 2 equal roots. You know, look at this now. Now, if I have a, let's say I have an x-axis, and I put y-axis over here. Right? And let me draw the graph in blue. Now, if the graph is down here, then you have 2 roots, 1 there and 1 there. All right. If I push the graph up, push the graph up this way, the graph like that. such that the minimum point comes up closer to the x-axis. There are two different roots there right now, you know, such that the graph is now like this. So what you find is that the two roots have come in closer towards each other in value. They are now closer to each other in value, right? But there are still two roots. They are now closer to each other in value. All right, so two values that are closer together. If I push the graph up some more, just imagine me pushing the graph up some more, then the graph would now like this. The two roots are even closer together in value now. They're coming closer and closer together. All right, and if I push the graph further up again, such that the minimum point is now on the x-axis, like that. Now what really happens is that the two roots now coincide and are now equal. So there are two equal roots there. Two equal, that's like they are now equal in value, but that's the two of them there, but like 1 point. Two equal roots. So there are always two roots. So when you have this situation here, or this situation, the front graph, you have two equal roots there and two equal roots there. But there are still two roots, and what they do, they call them repeated roots. Roots are repeated, roots are equal. And that happens when the minimum point is on the x-axis. That's this one. Or when the maximum point is on the x-axis, that's that one. All right? So you can have two equal roots. That's what happens there. Two equal roots. And there's also the possibility where I can push the graph further up such that it don't intersect the x-axis at all. What do you say in this case? In this case, you say that there are no real roots. The roots are not real. You still have two roots, you know, but they are not real. But you won't get this one in CSEC. You won't get this one in CSEC. They won't give you that in CSEC and ask you about roots for that one. Because the roots won't be equal. This third one is for add maths and pair maths. You will get this. These is what you will get at the CSEC level, the first two. So you can have two different roots on a quadratic function, or you can have two equal roots on a quadratic function, or you can have two imaginary roots down here on a quadratic function. But CSEC will not give you a question to find imaginary roots. So you don't have to worry too much about the third one. All right? Even if you get a graph like that, they won't ask you about the roots because the roots are imaginary, not real. They won't ask you about that. That is for higher level maths. All right? You get either the first one or the second one, not the third one. All right? So basically, that is that. So moving along now. So we come now to how do we solve it now? All right? Now, there are certain conditions that you must have before you try to solve it. The first thing is that you must put it in the standard form. Must have the equals 0. You must have the equals 0. That's the first thing. Before you try to solve any quadratic equation, you have to make sure that it is in the standard form first. So see, the quadratic equation must be placed in the standard form before we try to solve them. You must put it in the standard form. In other words, you must have the equals 0. Why is that so? Because the rules and the methods and the formula that we're going to use to solve quadratic equation, those rules were set up based on the equation being in the standard form. So if you're going to use those methods and those rules, you have to make sure that the equation is in the standard form first. And the standard form is when you have the expression equals 0. If you get a quadratic equation that is not in the standard form, you have to transpose it and put it in the standard form first before you try to solve it. All right? So that's the first thing, the most important thing. You have to put them in the standard form first. All right? So equation, examples of equations that are in standard form are those two equations, these two. That is in the y because we have the expression equals 0. This one is in the standard form, the expression equals 0. Those are examples when it is already in the standard form. So those two, we won't have to do anything. Go straight and solve it by whatever method. We're going to look at methods today. So these are examples where just go and solve it. We don't need to change anything. Examples of when they are not in the standard form. When they are not in the standard form, we say that they are in a basic form. Basic. We say it's basically a quadratic equation. And we don't solve basic. We only try to solve standard. So when they're in a basic form, they have to be rearranged into a standard form before you start to try to solve it. So don't even start trying solving it until you put it in a standard form. Very important. All right. So what are examples of them being in a basic form? That's an example of a basic form. So we don't have it equal 0, but we know it's a quadratic equation. You know, we know it's a quadratic equation. Look over here. 6 minus x squared equals 5x. It's an equation because we see the equal sign there. It is quadratic because the only variable in it is x, and the highest power of that is x squared. So we know it's a quadratic. Just that it is not in a standard form. It is in a basic form. So we have to transpose it and put it in a standard form, make it equal 0. So watch me now to get it in a standard form. And the next thing is, remember, you always want the x squared term to be positive when you're doing quadratic. It's easier when the x squared term is positive. So you must transpose it in a way that will make the x squared term positive. It's just easier that way. So when you have the opportunity to transpose a quadratic equation and make the x squared term positive, you do it. It's easier, you make less mistakes when the x squared term is positive. Not saying that it can't work when it's negative, and it can work. But what happens is that you have more chances of making mistakes when the x squared term is negative. Less mistakes are made when the x squared term is positive. So I want my x squared term positive. So because I want my x squared term to be positive, I'm going to transport it over to this side. Right? So watch this now. So when I carry this over this side, it becomes a positive x squared. I still have the 5x over here. And when I take this 6 over this side, it becomes negative 6. I'm left equals 0. So if 0 equals this, it is the same as saying this equals 0. And that is now my standard quadratic equation. So what I'm going to do, dash with that is basic, and work with this, that is standard. Dash with the basic, work with the standard. It's the same equation, you know. That's a different equation. It's the same equation written now in a standard form. We have transposed it to a standard form. There's no rule. There are methods to solve this as it is, you know. I'm telling you that this not be solved as it is. There are methods that you can use to solve that as it is. But those methods are not for CSEC level. The method for CSEC level is when it is in the standard form, not basic. This is what you solve. Solve standard. Don't solve basic. Mute your mic, please. All right? So that's what we're going to see over here. I've transposed it into the standard, and that's how it was done. All right? The example of a quadratic equation is that one, believe it or not. So even though we're not seeing the x squared yet, it is a quadratic because you can look. Let's look at it. You have x bracket 4x minus 3 equals 1. How do I know that's a quadratic? Because I can see that if I expand it out, I'm going to get a squared term here, so, and a term there. So if I expand it, let's go. I'm going to get 4 squared, because the x is the x squared right there. And then the x and the minus 3 is going to give them minus 3x equals 1. See, so I see it's a quadratic, but it's still basic. So I need to get this one this side and leave the 0 alone over there. So I'm going to transpose the 1 and get 4x squared minus 3x minus 1 equals 0. This is now standard. This is now standard. Solve this one. This one up here is basic. This one up here is basic. That. Don't solve basic. Right? Solve standard. This is the one that you have to solve. Solve this one. Dash with the basic and solve the standard. Don't solve basic at this level. Convert it into standard and then you solve it. Because when it is in the standard, you know what the A is, you know what the B is, and you know what the C is when it is in the standard form. So you must make sure it is equal to 0 before you try to solve. All right, so we're not even looking at how you solve it yet. We're just saying to you, make sure that it is standard before you try to solve. All right, so this is how I get that one. 4x squared minus 3x minus 1. And so we'll throw away these and solve these. Solve standard. These are basic. Don't solve basic. Basic. We solve standard. Always standard. So you have to put it in the standard form first, because the rules and the methods that we use to solve quadratic equations are based on the equations first being in the standard form. All right, so let's move on now. So the question now is, what are those methods to solve them? Next slide. All right, so the first method is to use a formula that is already set up for you to solve quadratic equations. And this formula is called a quadratic formula, and it can be used to solve any quadratic equation that is in the standard form. Quadratic equation can be used to solve any quadratic equation. All of them can be used to solve any quadratic equation that is in the standard form. So if you are in doubt as to what method to use to solve a quadratic equation, just use the formula. And the formula will be on the formula sheet in the exam. It's a formula that you need to know in your head. And when you practice it a lot, you will know it in your head, but it will be on the formula sheet. And it can be used to solve all quadratic equations. All right? So see it here. For any, I can put the word all right here as well. All, for any or all quadratic equation that is in this form, equals 0. Right? Has to be in that form, remember. Right? So put by the all right here. Right? The quadratic equation must be in that form. The formula is that the roots, when you solve it, you're gonna get 2 roots. You're gonna get 1 root with the plus. You see this for minus here? You're gonna get 1 root with the plus and 1 root with the minus. 1 root with the plus, gonna get 1 root with the plus, give you 1 root. And the minus, give it the other root. That's where you get the 2 root. X equals that formula. The plus give you 1 root, and the minus give you the other root. So all you need to do is basically just plug in the A, the B, and the C values in that formula, and you find the 2 roots. All right, and that formula that you need to know. So if you never see the formula before, you just start thinking about knowing this formula. All right, so formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now let me show you a mistake that people make with this formula. A common mistake with this formula is that persons write this. They write it like this: x equals minus b plus or minus the square root of b squared minus 4ac, and they put this alone over the a. It is wrong. That is wrong. Don't do that. It is all, everything divided by 2a. Note the difference. When you put this part alone over the 2a, you're gonna lose marks. You're gonna get the wrong side to put this part alone over the 2a. Some people even this minus b plus or minus square root of b squared minus 4ac over 2a under the square root sign there, which is wrong. So this is wrong. It is everything over 2a. Correct thing is this: x equals minus b plus or minus square root of b squared minus 4ac everything all over 2a. All right, so just like how we use the a, the b, and the c to find the xt and the yt, again, we're using now the a, the b, and the c to find the roots with this formula. This is a formula to find the roots. It's called a quadratic formula. This equation is called the quadratic formula. That formula is called a quadratic formula. So all we need to do now is do a couple of examples and see how we place the values, right? That's all we need to do now. So let's go and do a couple of examples. All right. So let's go and do a couple of examples with that. All right. Everybody good so far? Any questions?
Yes, sir.
Yes, sir.
Yes, you have a question, or yes, you're good.
Yes, so good, sir.
All right, good. All right, so let's look at the first one. Let's run through these examples quickly. All right. So the first one is 2x squared minus 3x plus 1 equals 0, right? I want to solve it. It is already standard. So because it is already standard, where the a is 2, the b is -3, and the c is 1. I'm going to drop it in the formula now. Drop those values in the formula to find the roots. So the x is equal to minus b plus or minus the square root. I don't have to rewrite the formula. I can just put in the value, but I'm just writing it this time. So going forward, I'm not going to write the formula. You must know the formula in your head and just put the values. You don't have to rewrite the formula. So anyway, minus b plus or minus the square root of b squared minus 4ac all everything over 2a. All right. Note the difference between this formula and the xt and the yt formula. This is the formula for finding the roots. So x equals, watch me now, minus, that is this minus. And then the b itself is -3. So it's minus -3. But everybody understand that just like the minus b over 2a that we did. Plus or minus the square root of the b squared, which is the -3 squared, minus, that's this minus 4 times the a, which is 2, and the c, which is 1. All everything over 2 times a, which is 2. That's it. When we put in the values for a, b, and c. All we have to do now is be careful and work it down. These examples that are set up for you easy, you know, some easy values. You're not getting any fraction or anything like that. All right. Most times when you have to use the quadratic formula, you're not gonna get these easy values. You have to get some decimals and stuff. You have to use a calculator. But I'm just doing this example with some easy values, just for us to see how the formula works. All right. So let's continue. So the x then is gonna be equal to minus 3, give me +3, plus or minus the square root. Now the -3 squared is going +9. 9 minus, that's minus 4 times 2 is 8. 8 times 1 is 8. Yeah, minus 9 minus 8 divided by 2 times 2, which is 4. But good so far? Once you don't understand anything, just stop and let me know. So this becomes x equals 3 plus or minus the square root of 1. Because 9 minus 8 is 1. Divided by 4. The square root of 1 is 1. But know the square root of 1 is 1. So you're going to move the square root sign. 3 plus or minus 1 divided by 4. All right. So how you get the two values now? You're going to get x equals 3 plus 1 over 4. Or that's the one with the plus. Or x equals 3 minus 1 over 4. So that's where you get the two roots. One root with the plus and the other root with the minus. That's where you get the two roots. All right. And so the first one comes 4 over 4, or the second one comes 2 over 4. 4 over 4 is 1, or that one is half. So those are your two roots. One root is a half, and one root is 1. Yes?
Like what you say,
Question?
Yes, sir. Like we said earlier, the larger root would be root one, and the smaller root would be root two, sir. Would it be okay for us
Yeah.
when we're doing this working out if instead of the x or x we put root one equal or root two equal?
You mean put one root equal? No, but you see, once you put the R, it's understood. Because sometimes it's not about finding roots on a graph, you know. Sometimes it's just solving an equation that give you two x values, which you're gonna see next week, for example. We're solving simultaneous equation for a line and a curve. And this thing is applicable not only in terms of a graph. We are learning it with respect to the graph. But sometimes it's just about finding two different values that satisfy an equation. You understand me? So what we know, so for example, if we were to make a little sketch of this situation, right? And we're relating it to the equation. It will be smile, to be a smile, right? To be the x-axis. One root will be a half, and the other root the one, right? And then the y-axis will be somewhere over here, right? And the y-axis intercept would be the c value. So the c value here, c value, this. If we try to relate the equation to a function, right? So here will be one, to cut the y here. So that's to be your two roots. In this case, we know the third point. Those to be your two roots, right? And the y-axis intercept is one. If you want to relate it to a function like that, where this function now, this function with y equals 2x squared minus 3x plus 1. And these are the two roots when you this thing equals 0. Understand? So I know that one root is a half and one root. So even though I get the half second when I solve it, I know that comes right there. Because half must come before one on the number line. Because x is like a number line, you know. That answers the question?
Yes, sir.
All right, good. All right, that's the first example. So far, so good. Let's do another example. Let's do this one. The second example is x squared plus 6x minus 7 equals 0. That's a quadratic equation. In the start form, to rearrange anything, we can just solve it. To solve it, we need the A and the C. We're using the quadratic formula. So the A equals 1, the B equals 6, and the C equals negative 7. C equals negative 7. All right, I will proceed again. Now I'm just going to put the values now. I'm not going to write the formula again. So the formula over here. The formula over here, if you want to look at it. All right, I'm just going to put the values now. All right, so see it here now. The roots are x equals minus b minus, and the b is 6, plus or minus the square root of b squared. The b is 6 squared minus 4ac. 4 times a, 1 times c is negative 7. Everything over 2a. 2 times 1. 2 times 1. Good? And you work it down. X equals minus 6 plus or minus square root 36. The 6 squared is 36. Now watch this now. Minus 4 you know. Minus 4 times minus 7 give you a positive. 4 times is 28. Right? Minus times minus give you a plus. So the minus 4 times minus 1. Minus 4 times 1 is minus 4. Then minus 4 times 7 is a positive 28. 7 4 is 28. Right? All over 2. All over 2. So far, so good? Very good so far?
Yes, sir.
Yes, sir.
That's the answer, you know, guys. That I know that everybody on track, you know. Right? Hold on. Hold on a second. All right. So where are we now? All right, good. So far so good, everybody, right? And so x comes equal to -6 plus minus. Now the 36 and the 20 is actually now 64. Yeah, that's 64. Square root of 64 divided by 2. Now everybody know the square root of 64 is 8. So we can move square root sign and put 8. So x equals -6 plus or minus 8 all over 2. And then now you're gonna get 1 root with the minus, 1 root with the plus, 1 root with the minus. You're gonna get x equals -6 plus 8 over 2, or other rules, x equals -6 minus 8 over 2. All right, I'm going step by step for you. So x equals, this is the same as 8 minus 6. 8 minus 6 is 2. So you get 2 over 2, or x equals is -6 and -8, that's -14. So you get -14 over 2. And so one root is 1, or the other root -7. Those are your two roots. Right? Those are your two roots. And if I want to relate these two roots now to the function, I relate the equation to the function, but I would have a smile. I'm relating this function will equal x squared plus 6x minus that we got the equation from, right? So relating it to the function now. The function would be a smile with root 1 and -7. So it will be like this. 1 and negative will be the two roots. So it will be more to the left. -7 is more to over the side. Right? So it's like this. Something like that. It will be 1 and root is -7. And notice the y-axis intercept is -7. So this the y-axis intercept down here, -7. That is it. That will be the function there now based on the information that we have. Going point computing the square with the working with the roots. Understand? I'm gonna tell you something about the relationship between the roots. Tell you something later on. Right? If I don't tell you something about the relationship between the roots and the turning point, the xt value, remind me of the class over, right? But I don't want to digress from this. I want us to solidify before we proceed. So far, so good. So far, so good.
Yes, sir.
This negative
Yes,
is
sir.
this c value. All right. Again, another example. All right, watch me now. Pay attention, buddy. Pay attention, right? Pay attention. Remember, I'm doing something wrong here. Good enough, but sometimes I make mistakes. I'm gonna stop me from making any mistake. Don't wait till I go too far. Right? All right. So make we go. All right. So the next example now is this now. Third one. X squared plus 5x minus 4 equals 2. So we're gonna solve this one now. All right. So if we're gonna do on the A, B, and C first. So A is 1 and the B is 5. The C is -4. Very good? That all right?
Yes, sir.
Very good so far?
Yes, sir.
All right. Everybody agree with that?
Don't we have to change it? Don't we have to, doesn't it have to equal to 0?
Exactly. Exactly. It has to be equal to 0. You cannot get the A, the B, and the C unless you put it equal to 0 first. That's why I just said to you. That's why I said to you before I started. If I'm making a mistake, stop me. Because I know I deliberately was going to make a mistake. You have to see that this is a 2. This is not 0. Everything important. I spent the first couple minutes talking about that the equation has to be in the standard form first. It has to be equal 0. So this is just a basic equation, you know. This basic, if you know standard basic, this is basic. So that is wrong. Don't solve basic. Make it standard first. And I've seen CSEC do that. Then put a value over here so until if you solve it and people just start solve and get it wrong. It has to be 0 over there. If it's not 0 over there, you have to transpose it and move the 2 and leave 0 over there. That way you can get the value of A, B, and C correctly. All right? So I deliberately made that mistake. Sometimes I have to make the mistake so that you can learn from my mistakes as well. So I deliberately made that mistake. So you can learn, and we emphasize the point that it has to be standard. It has to be standard. So that is basic. So we don't solve basic, erase all of this. Don't solve basic. It is a basic equation. We have to transpose the 2 and make it standard first. So we're going to carry this 2 over the side and leave 0 on the right side. All right? So we carry over the 2, transpose it to make it standard. You get x squared plus 5x. When you carry over the 2, it's going to become negative 2. So negative 4 and negative 2 is now negative 6 equals 0. This now is standard. This now is standard. We don't solve basic. I swear that. Don't solve basic. It's the same equation, you know, but we have put it in a standard form. Don't try to solve basic. Solve standard. So this is what we're solving now. Here now we get the correct A, B, and C. The C a while ago up there was wrong. Right? The A now is equal to 1. The B is 5. And the C is negative 6. A while ago we put negative 4 for the C, which is wrong. This is what we're solving now. Standard. Alright? So let's continue. Hope everybody remember that. So proceeding now. So now that we know, we're going to say the x equals minus b. So that's minus b. The b is 5 plus or minus the square root of b squared. That's 5 minus 4 times a. The a is 1 times c. The c is negative 6. All, everything, all over 2a. 2 times a. The a is 1. And once you have the values there, you know, you take your time and you write them down carefully. So the x equals minus 5 plus or minus the square root. 5 squared is 25. Watch this now. The minus 4 times the minus 1 is minus 4. Then minus 4 times minus 6 is positive 24. You have to be careful with the negative signs. Minus minus is plus. So we're going to a plus 24 right here. All over 2 times 1 is 2. Alright? Then it becomes x equals minus 5 plus minus square root of 49. I'm giving easy values in this example, in these examples. Divided by 2. The square root of 49 is 7. You have to know these things, these perfect squares. So we're going to remove the square root sign and put 7. Don't put by the square root sign. So x equals minus 5 plus or minus 7. So minus 7. Move the square root sign. Divided by 2. They're going to put the 2 roots now. One with the plus and one with the minus. So x equals minus 5 plus 7 over 2. Or the other root is x equals minus 5 minus 7 over 2. I'm going step by step again. X equals this here my 7 minus 5. So 7 minus 5 is 2. So that's 2 over 2. Or x equals minus 5 and minus 7 is minus 12. Minus 12 over 2. So x equals 1 or x equals negative 6. 12 over 2 is 6, so that's negative 6. And if I relate the 2 to the function now, And so the function has to be the standard and on the original thing that they gave us. Not this one here. Has to be the one that was solved. The standard one to relate back to the standard one. Standard one was based on y equals x squared plus 5x minus 6. That's one that we solved for. Right? We're doing that and we got roots of 1 and negative 6, similar to one that we did a while ago. 1 and negative 6. So it's gonna be more to the left. And negative 6 is further over to the left. Alright, so we scale that. We're gonna get it like that. Where this is 1 root 1. This root is negative 6. And this y-axis intercept is negative 6 right there. Negative 6. We can put 0, negative 6 for the y-axis intercept. Alright, and basically it is that. That's sketch. Alright, and the last, fourth one. Let's do the fourth one. Fourth one is x into 4x minus 3 equal basic. Is a basic equation. Basic. We don't solve basic. So we convert standard form, expand it out and set it out in the standard form first. So you're going to expand it out and you're going to get 4x squared. That's this times this. And then this time this is minus 3x. Minus 3x. And cure 1 same time. And above the negative 1 equals 0. This is our standard equation. And so solving standard. Now that is standard, can get the A, the B, and C. The A equals 4, the B equals negative 3, C equals negative 1. All right, and we're ready to solve. It is standard, we're ready to solve. We know the A, the B, and the C, and we're using the quadratic formula. So x becomes minus b, and the b is negative 3. Bracket it, or we can leave it unbracketed. Let's leave it bracketed for now. So it's minus b plus or minus square root of b squared, negative 3 squared. The b is negative 3 minus 4ac. 4 times a is 4, the c is negative 1. Keep all those negatives. All everything divided by 2 times a. The a is 4. The a is 4. Write down the values. X equals minus minus plus 3 plus minus square root. The negative 3 squared becomes positive 9. Negative 3 squared is positive 9. Then working this out. Minus 4 times 4 is negative 16. Negative 16 times negative 1 becomes a positive 16. So that becomes a positive 16. Positive 16. All over 8. All over 8. All right. And then this continues. X equals 3 plus minus square becomes what? That becomes 25. 25. 16 and 9 is 25 over 8. And everybody knows the square root of 25 is 5. So you move the square root sign and you put the 5. So x equals 3 plus or minus 5 over 8 plus minus 3. 3 plus or minus 5 over 8. You're going to get one value with the plus, one value with the minus. X equals 3 plus 5 over 8, or x equals 3 minus 5 over 8. Let's go again. X equals 8 over 8, or x equals minus 2 over 8. And this one reduces, so x equals 1 or x equals minus 1 over 4. So those are the two roots. All right, and if we relate it back to the standard equation up here, the standard equation, relate the function to that standard equation there, which was y equals 4x squared minus 3x minus 1 minus 3x minus 1. We're relating the equation, the standard equation, to that function. Right? That function would have root 1 and negative a quarter. So y-axis, x-axis, and it will have a smile. This will be minus a quarter on root. It will be 1 the other root. And the y-axis intercept would be negative 1. So this would be 0, negative 1. 0, negative 1 from that point. All right, based on that. So that is using the quadratic formula, guys. You just need to practice. It's very easy. All right. So if you're doing a quadratic equation and you're in doubt in terms of how to solve it, you can just use the quadratic formula. The problem though is that you have to learn factorization. The other method of solving a quadratic equation is to do it by factorizing. But you have to learn to factorize anyway, because there are questions on the exam paper that will ask you to factorize quadratics, which is the other method. All right, that is the other method. All right, hold on a second, guys. Hold on a second. I'm getting a call here from work. Hold on a second. All right, guys. Sorry about that. It was a call from work. So let's take that. But can you hear me now again?
Yes, sir.
Right.
Yes,
Can you hear
sir.
me? Let me know that you hear me, please.
Yes, sir.
I can hear.
Yes, sir.
Yes, sir.
Oh. Hello. Hello.
Yes,
Hear
sir.
me, sir.
Yes, sir.
Hello.
Sir, you're not hearing us, sir.
All right, cool.
Yes, sir.
Yes, sir.
Yeah, some apparently it's headphone giving some problem. I need to change it, but all right, let's just continue now. All right, so moving on now to the other method of finding the roots, which is factorizing. All right. Now, some persons don't like to factorize, but you cannot avoid it, because as I was saying, question 2 and question 3 in the exam, they will ask you to factorize quadratic expression. So you have to know how to factorize. So even though all the quadratic equations can be solved using the quadratic formula, you still need to know how to factorize quadratic expressions. All right, it's a method and a skill that you must develop. All right, so that's what we're going to look at now. So this is using factorization. Now, the thing about it is that where the quadratic formula can be used for all quadratic equations, right? Basically speaking, the factorizing method can only be used for some. That's why I have the word some here. For some quadratic equations, right? We use a factorization method. I remember when we spoke about the quadratic function, we spoke about the 3 different forms. We spoke about the standard form, the vertex form, and the factor form. This is one where we're sort of applying the factor form somewhat in a kind of way. All right, so the note is based on that. So the expression can be written in the factor form or the factorized form, which is similar to that. A into x minus r1 times x minus r2 equals 0. Now, r1 and r2 will be your 2 roots. So when you factorize it, you're able to sort of identify the 2 roots. All right, now this is really a times x minus r1 times x minus r2 equals 0. Now, a is a constant I would know. For example, a will be 2 or 3 or 4. A will be a constant, right? And so we can divide both sides by the a, all right, to get rid of that a. And if we divide both sides by the a, then the equation becomes that. That is if we divide both sides by a. We divide out the a and end up with that. Now, when you have this equation, right? This equation is this expression multiplied by this expression equals 0. Right? And 0 is a special number. That's why we have to put the quadratic equals 0 now. That's special property of 0. The special property of 0 is that if you multiply two numbers and the result is 0, then one of those two numbers you're multiplying must be 0. That is the property of 0. That is why the method that we're using is one we have to put it in the standard form. That's how the 0 comes into play in this method now. We're using that special property of 0, that if two numbers multiply together equals 0, then one of those two numbers must be 0. Either the first number is 0 or the second number is 0. That's the theory behind the use of the 0. And that's why it's so important that we have to put it in a standard form first when it is equal to 0. All right? And so that is it. Either the x minus r1 equals 0 or the x minus r2 equals 0. And then now, if the x minus r1 equals 0, you just transpose the minus r1 over to this side. And so the x will be equal to r1. And if the x minus r equals 0, then you transfer the r2 over onto this side. And then the r2 would then be equal to 0. That's the theory behind it. We're going to actually work it, right? So that is how we get the two roots. All right. So the two roots will be x equals r1 or x equals r2. That's a theory, theoretical aspect of it. So the question is, how do we factorize and get from the standard form to the factorized form? How do we do it? That is what we're looking at now. Is it? Right? Factorizing the quadratic expression so that we can get the two factors. Put the two factors equal 0. Either one factor is 0 or the other factor is 0. And then when we know the two factors, then we can know the two roots. Because if we know the factors, then we automatically will know the roots. All right? So the method that we're going to use, I'm going to write out the method here, but then you'll understand it more through my demonstrating how it is done. And it's something that you have to practice, how you factorize the quadratic expression. All right? And it's a method that I call splitting the middle term. All right? You see, the quadratic expression has 4 terms in it. 3 terms in it. Sorry, that's 2 terms. And what we want to do, because remember now, when it is factorized, right, we essentially have 4 terms. 2 terms on here, 2 terms on there. So the idea is to break it, split it out from 3 terms and convert it into 4 terms. All right, that's what we want to do, convert it to 4 terms. So to convert it to 4 terms, into 2 terms, split the middle term into 2 terms, but you have to split it in a specific way. You can't split it in a random way. You have to split it in a specific way. And the method to split it so that it will be able to be factorized is, first step is to multiply the 2 n values, the a and the c, the 2 n coefficients, the a and the c. We're trying to find the factors that I want to use to split the b. All right. Then after I find a and the c, then you find factors of the product of the multiple a, c, such that when you add those 2 factors, they add back to the middle coefficient, which is a b. If you don't understand what I'm saying here, don't worry about it, right? When I start to do the question, you'll see. You can always go back and look at this and you'll understand it. So if you're not understanding what this means, don't worry about it too much, right? When we do it and you go back and look, you'll see what it means exactly. The third step is split the middle term using the 2 factors that were found in step 2. So the first step is to multiply the a and the c. They search for factors of the AC that add to the b. And then after you find those 2 factors, you split the bx using those 2 factors. And then after you do that, you break it out into 4 terms and then you factorize by parts. That is a 4 steps method. All right. And the best way to do this is to demonstrate it with some examples. All right. So let me do a couple of examples from this. I'm going to do them on the right side over here. All right. So let's start with the third one. So let me start the third one, which is x squared. Let's start with the first one. So it's sometimes when they're too easy and really demonstrate so good, you know. Let's start first one. 2x squared plus 3x plus 1. All right. So the first step is to multiply the 2n coefficients, which is 2 times 1. 2 times 1 is equal to 2. All right. Then you're searching factors of 2 that give you the midterm, which is a positive 3. Factors of 2 that add to positive 3. That's what you want. And you're searching for those two factors down here. And it's very easy because the only two factors of 2 is 1 and 2. Right? The only two factors of 2 is 1 and 2. Factors of 2, 1 and 2. That's why I never want to bother with the first one. Okay, 2 easy. Factors of 2, 1 and 2. Right? And factors of 2 that add to 3, 1 and 2. So there are factors of 2, and when you add them, you get 3. So you actually find it already. That's why this one really demonstrated so well. All right, so you're going to split this trace into 1x plus x, or 2x plus 1x. All right, so you might not see it so clear with this example, you know, because it's too simple. So that equation becomes 2x squared. No, not 3x squared, x squared. It becomes 2 squared, 2x squared, and then the 3x in the middle becomes 2x plus x, 2x plus 1x, 2x plus x. If you want to put 1 front it, no problem. 2x plus 1x. The reason why I put the 2x first is I want to be able to factorize 2x in there. All right, that's why I put x first. I put as 2x plus 1x. So that's my middle term. 2x plus 1x. And I say these two add back to the x that I add in the middle. And now back my plus 1 there. All right, so the 2 middle to add back. And then what happens next that you factorize these two terms. All right, so you factorize the highest common factor in those two terms is 2x. When you factor 2x out of this, you're left with x. Factor 2x of this, you're left with a plus 1. And you write back the same thing in the bracket, you have to write back over here as well, x plus 1. This one not really sure it's so good enough because you know the value is too simple. When you put back the x plus 1 over there, you look what factorized on this 1x. So it's 1, remember. All right, it's plus 1x. This one not really understand so good from this example. I'm going to set up a different example. All right, from the plus 1 here to get this in, you have to factor out a plus 1. So you have to out a 1 right here. And then what happens now? The x plus 1 becomes a common factor in this line. X plus 1 is a common factor. Plus 1. All right, and so you get 2x plus 1, 2x plus 1 times the common factor of x plus 1. This is a common factor of x plus 1. I know if you don't understand from this one, I can understand. So don't worry about this one. Let's do another example. This one I really demonstrate well. All right, so let's do one with some figures. Let's do this one. Let's do this, the third one. The second one is solve. So the ones over here are to factorize, and over here are solve using factorization. Let's do the second one, which is 3 squared minus 7x minus 6 equals 0. We're solving that by factorization. We're not using a formula to factorize this expression first. All right, so this one will maybe explain it a little bit better. So pay attention now. Pay good attention now. Right. So the first step is to multiply the 2n coefficient, which is 3 times negative 6. Multiply the a and the c. The a is 3 and the c is negative 6. Now 3 times negative 6 is negative 18. Negative 18. Negative 18. You're searching for factors negative 18 that add negative 7 middle term. Searching for factors of negative 18 that add to negative 7. Oh, listen good now. A factor of negative 18 that add to negative 7. So you're going to search for the factors. If you can't see what they are right away, you search for them. Now, since you want factors of a negative number, the negative 18, one of the factors will be positive and the other factor will be negative. You're going to give the larger of the two factors the same sign of what is up here, which is negative. So the larger factor will have a negative sign. All right, so let's search for the factors that we want. The first two factors of 18 are 1 and 18. Give the larger one the negative sign and the smaller one positive sign. Those are factors of negative 18. But when you add them, you get a negative 70. So 1 and negative 18 add to negative 17. You don't want negative 17, it's negative 1. So that's what you want. So put an X on that. You don't want that. So you go to the next two factors of 18. The next two factors of 18 are 2 and 9. Are the next two factors of 18. Remember, you're searching for factors. Right? You're searching for factors down here. Factors. You want factors that add to negative 7. The negative 7 come from this. All right? So 2 and 9. Give the larger one the negative sign because this is a negative sign. And give the smaller one positive sign. Then 2 minus 9 is actually negative 7. So yes, you have found it. You have found the two factors that add to negative 7. So what it means is that you're going to split this negative x into 2x minus 9x or minus 9x plus 2x. So what happens now? Now that you find it, you're going to get the split now. You're going to split the middle term. So the equation up here now becomes, you're going to split it now. It becomes 3x squared, and then the minus 7x will become minus 9x plus x. That is it. That's minus 7x, you know. And they are about minus 6 equals 0. See that? So this minus 9x plus 2x is minus x was. Alright? So we split. Why did I have minus 9 first? Because I want the minus 9 factorized with the 3. If I put the 2x in front, it doesn't matter. You get the same two factors anyway. Not that it's going to be wrong. In other words, instead of writing minus 9x plus 2x, I could have written 2x minus 9x. I could have done that just the same. I will get the same answer when I'm done. All right? So no matter which order you put it. All you know is that they must give you back. They must give you minus 9x, minus 7x. Must give you back the minus 7x. All right? So I'm factorized now. So I'm going to factor the first two terms and factor the second two terms. But the key thing is that the two brackets must have the same thing. The two brackets must have the same thing. All right, right now. Highest common factor in the first two terms is 3x. 3x is the highest common factor in those first two terms. When you factorize 3x out of the 3 squared left x, you factorize straight out of this, like a divide or 3x out of it, you left with negative 3. And what I said is that the x minus 3, what is in the bracket, must have minus 3 here as well. So I always put that first because the two brackets must have the same thing. All right. Then I'm going to look from a put here must plus something or minus something must always go out there. Or you know what must go there. Because if you're plus right and you're factoring the x, you must have factored out negative 2 down here. Negative 2. Not negative 2, positive 2. Let's start again. Let's start again. All right. So I put the same thing in it here first. And then I look at this. From that, I factor and get an x in here. So it means that I must have factored out the positive 2. Positive 2. And then we can check if it's right, because positive 2 times x is positive 2x, and positive 2 times negative 3 is positive 6. So that's one factorize good, right? And this is equal to 0. So then the x minus 3 is my common factor, and so becomes x plus 2 times my common factor. Here, 3x plus 2, that's from this and this, time my common factor of x minus 3 equals 0. And that's it. I have factorized it. Now that I've factorized it and it equals 0, is either this part equals 0 or this part equals 0. So see now, either 3x plus 2 equals 0 or x minus 3 equals 0. Not x equals 3, x minus 3. X minus 3 equals 0. The product of those things equals 0. Either the first one is 0 or the second one is 0. And then from this now, if I want to find the x, I just cover the 2 first, and I get 3x equal minus 2. And then I divide by the 3. Divide both sides by 3. And when I divide side by 3, x equals minus 2 over 3. For this one, all I have to do is just cover the 3. Positive. So this one is me x is or x equals 3. So those are my two rules from this equation, from this one. That's it. All right. Let us do the let us do the one immediately below it. Any questions? You ask me. You just need to practice. Once you keep practicing and do a number of them repeatedly, then you'll see your way through. All right. It's not difficult. It's very easy. And eventually we'll be able to do them even quicker, shorter. All right. So let's do the one below it. Let us do the next one. The next one is x bracket 2x minus 1 equals c. Let's do that one. That's a quadratic equation, but it's basic. So the first thing you have to do is convert it into standard, expand it out and transpose it out into standard. Then we're going to use a factorization method to solve it. All right. So when I expand it, I'm going to get 2x squared minus x squared 15, it becomes minus 15 equals 0. But understand? But understand what I get, right?
Yes, Daddy.
Equals 0. Now remember, the number this is really negative 1, you know. With a negative 1 there. All right? I can put it or I can leave it. So watch this now. Then I'm going to split it now. I'm going to split the middle term now. Factorize it. Factorize the quadratic. First step, by the a and the c, 2 times negative 15 equals negative 30. Negative 30. I want to factor of negative 30. That gives me the coefficient negative 1. But the negative 1 is what is right here. Is imaginary 1 there, negative 1. So on factor of negative 30, that add to negative 1. All right. Now, if you can't see the two factors right away, you can search for them down here. Search for the two factors. All right. Let's search them under here. The first two factors, if you can't see what they are right away, you go on the list of factors. Start with 1 and what? 2 and what? 3 and what? 4 and what? 5 and what? And search for all the factors. All right. So the first two factors of 30 would be 1 and 30. Since you want factors of a negative number, one will be positive, one will be negative. Give the larger one the sign this that you want. So the larger one negative and the smaller one positive. But the problem is that 1 minus 30 is negative 29. You don't want negative 29, you want negative 1. That won't work. So go to the next two factors of 30, which are 2 and 15. Give the larger one the negative sign and the smaller positive sign. But 2 minus 15 is negative 13. You want negative 1 to cross that out as well. The next two factors of 30 are 3 and what? 3 and 10. So you see, I'm going down the list of all the factors of 30. Give the larger one the negative and the smaller one the positive. But 3 minus 10 is negative 7. You don't want negative 7 cross out as well. Right? That won't work. So the next two factors of 30 is 4 and what? 4 and nothing. The next one is what? 5 and what? 5 and 6. The next two factors are 5 and 6. The larger one negative and the smaller one the positive. Then 5 minus 6 is negative 1. Yes, negative 1. See, negative 1. So what it means is you're going to split this negative 1x into 5x minus 6x. I can put the minus 6 plus 5x. All right? So now you're going to split. Take this now. And you're going to split it. You're going to split the negative 1x. So it becomes 2x squared. I'm going to put the minus 6x first. Minus 6x plus 5x. So this is what was negative 1x a while ago. And then I have a negative 15 equals 0. So always check that you split the middle term into is it what was there before. Always check. Right? Always do that check just to make sure. Then I'm factorizing by parts. Highest one factor the first two terms first is 2x. Factorize 2x out of those terms. 2x. So this leaves me with an x. So out of this leaves a negative 3. Put back x minus 3 in the bracket over here first because the two things must have the same thing in the bracket. Then I look at this. If x is factored side here, it means that the plus 5 is factored out here. I'm factorizing out plus 5. All right? Got the plus 5. So put plus 5 out here. And then you check it. 5 times x is 5x. 5 times negative 3 is negative 15. So you know the factor is good. No is equal to 0. Then what happens now is that x minus 3 is a common factor. And so it becomes 2x plus 5 times the common factor. So the next line is 2x plus 5 times the common factor of x minus 3 equals 0. And then once you have that now, you know that either d equals 0 or t equals 0. Here, 2x plus 5 equals 0 or x minus 3 equals 0. Right? One of those two must equal 0. If this multiplied by this equals 0, then either this part equals 0 or this part equals 0. That is the concept. One of the two must equal 0. One of the other equals 0. And then you solve them. So t equals 0. Quick now. Over the 5 become negative 5 and divide on the 2 to make it. The x is going to be carry over the 5 first, become negative 5 and divide on the 2. So the x equals minus 5 over 2. Or this one just carry over the negative 3 alone. And so x equals positive 3. So those are the two roots from that equation there. Any questions? Very good.
So we get the negative
Just need to
again.
practice. I'm gonna get the negative 5 over 2.
Yeah.
So you asking me? Become over this 5 first, become negative 5, and then divide 2. And that x as a subject. I think it's in one step now. Improve as you go. See it? Get over
Yes,
the 5
sir.
first, get negative 5, and then divide under the 2. Good? As we go, we're gonna cut out some steps that are unnecessary, you know. As we go more and more, and understand it more and more, we cut out some steps that we don't need. Carry over the 5, you become negative 5, and then divide under the 2. So become negative 5 over 2. X is negative 5 over 2. All right, let's continue. Let's do the last one on the page. The 8x minus 2x thing. Let's go. Next one. So now we're doing in the next example. 8x squared minus 2x plus 1 equals 2. All right, now that is not standard. First thing we have to do is carry over the 2 and make it equal 0. That is basic. So we carry over the 2, we're going to book ax squared minus 2x minus 1, because 1 minus 2 is going to become minus 1 equals, what is standard? So that is, that's where it's called basic. It's basic. We don't have basic. Right? Always have standard. That's really basic. This is basic. This we're solving, but that is standard. We already know the easy one. So when I multiply the 2n coefficients, the a times the c, so that's 8 times negative 1, negative 8. We want factors of negative 8 that add to the middle coefficient of negative 2. Since we want factor negative 8 here, one factor will be positive and one factor will be negative. Give the larger factor the sign of what we want up here, the same sign. So the larger factor must be negative. All right. So if you don't see those 2 factors right away, you go down the list of factors. The first 2 factors of 8 are 1 and 8. Give the larger one negative sign, small one the positive sign. The problem is that 1 minus 8 is negative 7. We don't want negative 7, so that's not what we want. So go to the next 2 factors of 8. The next 2 factors of 8 are 2 and 4. Give the larger one negative and the small one the positive. But 2 minus 4, 2 and minus 4, negative 2 is what you want. So good. So it means that we want to split this negative x into 2x minus 4x. That negative x into 2x minus 4x. So I found the factors that we want. So the equation here becomes 8x squared. Then we split the middle term into plus 2x minus 4x. This is what was negative 2x a while ago. Now put back minus 1 equals 0. So we'll split the minus 2x into 2x minus 4x. We'll break it out into 4 terms so that we can factorize the parts. We can factorize these 2 and factorize those 2. Factorize by parts. That's why we'll put it into 4 terms. All right. Then we'll go. Higher common factor in the first 2 terms here is 2x. So you factorize the 2x. When you factorize 2x out of this, you're going to get 4x plus 4x out of this, give me 1. Safe thing to do is to put back 4x plus 1 in the bracket. Sitting in the bracket, end up in the bracket there. So about the sitting in the bracket. Watch this now. From a negative 4x, the 4x gone inside here. So you must have factored a negative 1. Look here. Don't just factor a negative, you know. You have to always factor out a negative value, a negative something, or a positive something. In this case, that something is 1. Factor out a negative 1. Negative 1. And this equals 0. Factor out a negative 1. All right? That's what you get. Factor out a negative 1. It's always factor out a negative something or a positive something. You can't factor out just a plus, or you can just factor out a minus. It has to be a minus value, minus something, or a plus something you factor out. Because you want to know what must go in one of the brackets. So since the 4x one is a common factor, it becomes 2x minus 1 times the common factor. That's why it has a minus a value or plus a value right there every time. All right, so you factor out the 2x minus 1, the common factor of 4x plus 1 equals 0. All right, I'm going to skip another step right here, so now. Skip another step right here, so now. Think of it now. Either it's equal to 0 or this equal to 0. One of those two. Just think of it that way. Either this thing equal to 0 or this thing equal to 0. So we can skip a step. Watch it. All right. Now, firstly, if this is the y equals 0, let's try it for the x equal to now. The x will be equal to, here me now, carry over the negative 1 first, becomes a positive 1, and then divide on 2. Divide under the 2. That's the answer for the first bracket. Or, second bracket, if this one equals 0, what would happen? I will carry the negative over the 1, I come negative 1, and then divide under the 4. Alright? So I would carry the negative 1, I will get carry over the 1, x equals carry over, I get negative 1 and divide under the 4. So those will be my two rules. Hopefully, set. Let's see that. Nobody see that? Those
Yes,
are my
sir.
examples. Right. So all you need to do, guys, is practice this thing. Practice, practice, practice. All right. I'm gonna practice. I'm gonna do the homework questions and practice, practice, practice. And that is how you solve the equation using factorization. You have to factorize it first. Right? Factorize it first. Right? Hold on a second. All right. So this is a factorization method. No matter how many I do, you have to go and do them by yourself. Make your mistakes and learn from your mistakes. What you need to do is work these that I've done, work them over by yourself before you do the examples in the homework. All right. Before you do the examples in the homework, you work them over by yourself. So it's basically homework number 2. We want to finish the class yet, still have other types of factorization to do. All right. So other forms of factorization that they must know. All right, which is what is on the next slide. So that is a factorization you have to practice. We're gonna do a lot of them, and you'll eventually get it. All right. So remember, to solve a quadratic equation is either use a quadratic formula or use a factorization method. Factorization method, you have to practice the steps. You have to practice the steps. All right. And we're gonna do some more examples tomorrow in tomorrow's class. But tomorrow's class is about practicing questions. So we're going to practice some of the quadratic formula and practice some amount of the factorization tomorrow. All right, but I want you to do these questions, these examples that I did today. I want you to work them over by yourself and see if you get the same answers. All right, before you try the homework questions. All right, let's look at the other forms of factorization that you need to. All right, before we end the class. Okay, maybe do a one question before we actually finish the class. Time is it now? 1:05. All right, yeah, so we're coming close to the end of the session for today. So let us look at the other types of factorization that you need to learn for your CXC. Let's look at them. All right. So there are about 5 types of factorization, mainly 5 types. Sometimes they vary them a little bit more than just these 5, but these are the 5 basic types that they set in CXC. Now, the advantage with doing this class and doing the notes is that if you know the type of factorization that you're supposed to get, then you'll be able to identify it and you'll know what method to use to factorize it. So we're looking at the method of factorizing. We just did the quadratic a while ago, which is the method is one where we try to split the middle term, and it's a 5 steps process, and we looked at them a while ago, right? You just need to practice those steps. Right, and now we're going to look at the other types that you can get, the 5 types. Right, there are 4 other types to look at. We did one already of the 5. All right, so let's look at them. I'm going to just work a couple examples with each one as we look at them. Look at the example. Let's make this a little bit smaller. All right, so the first one is factorization by parts, or factorization by grouping. I'm just going to do 2 examples. Now this one, they are usually 4 terms. So when you get a factorization question in the exam, I say 4 terms. It's usually a factorization by parts method that is required, or what we call factorization by grouping, right? And those are 2 examples, right, which I'm going to do now. All right, so listen to me carefully now. You see, sometimes you have to rearrange the values to make them friendly, right? Friendly to the factorization process. All right, so the first example is 2ms plus 3mt minus mt minus 3ns minus 3nt. 3nt. So basically that's what we're factorizing, right? Now, what you want to do, you want to know if you need to rearrange the values. So how I normally look and see if I rearrange the values, you sort of think ahead a little bit first. So you're going to factorize the first 2 terms and second 2 terms, but you have to ensure that they are friendly because you want the same thing to be in the bracket, in the 2 brackets. So for the same things in 2 brackets, the values must follow in the same order in the 2 parts. In the first part and the second part, the values must follow in the same order. So I'm looking at this and I'm saying, okay, if I factorize the m out of these terms, because the m will be one factor in 2 terms, I would have a s in the bracket followed by a t value. So what I want in the second terms to have a s value followed by a t value, which that is the case, and so there's no need to rearrange the values. Since my s follows my t in the first 2, and t follows s in the first 2, and t follows s in the second 2, it means that there's no need to rearrange the value and proceed with factorizing parts. All right, that is the approach. That is what you look for. All right, and then let's go ahead and factorize by a part. So the highest common factor in the first 2 parts is m. When you factorize m, you get 2s plus 3t. Then I write by the same thing in the bracket. 2s. No, I'm wrong. M is a common factor plus m. So I get 2s. Oh, this is not 3s over here. So this is a 2s. My mistake. That is 2ns. Right. So I have to write 2s plus 3t in the bracket over here as well. Whatever is bracket here, same thing must be in the bracket there. Very important. If you put 2 different things in the bracket, you're running into problems. You must have the same thing in the 2 brackets. Then now that I've placed bracket there, I have to look at this now. And I look and say the 2 factor in already, and the s factor in here already. So it is the negative n must factor out. I must factor the negative n outside. All right, negative n. I'm going to factor out the negative n. So factor out the negative n. And remember, it has to be plus something or minus something factored out. And then you check it. The negative n times this gives me that. Then now, the negative n times the tt gives me negative 3nt. So that's how I know that the factorization is correct. And then now the 2s plus 3t is my common factor. And so I get m minus n. M minus n. M minus n is my common factor of 2s plus 3t. And that's it, I'm done. Right? And that's always the result. You always get a double bracket like that where you factorize 4 terms. Factorized by parts. I always get a double bracket like that. All right, that's the first example. Second one is 3b minus 8r minus 4pr plus 6 to factorize. If I look at the first 2 terms, there is no common factor. So it means that my values will have to be rearranged. My values have to be rearranged. All right, so what I'm going to move this with the p. to represent that P. Remember, I'm shifting them around in the same expression, you know, so the sign don't change because I'm just shifting position. Right? It's example like me 2 plus 3 plus 5. I can rewrite it as 2 plus 5 plus 3. This here and put it there, but the sign in front don't change. If this was a minus, for example, this was a minus, this would be a minus. Right? I've rearranged it in the expression, but I don't change the sign. Right? I don't change the sign. The same thing up, you know. So I'm gonna rearrange it, right? So I'm gonna rearrange it and write that 3p minus 4pr. And then I need to put these two as next. So the question is, which one do I put first? Now, if you notice, in the first two terms here, the term r comes as second. So these two terms that I have left to place, I want term r to come second. So I have to put the plus 6 first. I'll put the plus 6 minus 8r. Because the r term comes second, I want r term to come second again. Those two. So that's why you have to rearrange it in a friendly manner. Then once you have it set out like this, then you can proceed with the factorization. The highest factor is 2 terms is just p. So you factor the p first, and you get 3 minus 4r. You factor the p. What did we say? You must have 3 minus 4 in the bracket here as well. Whatever is this bracket, most in that bracket. So might just write the bracket term first. Then look, a positive 6 factor that 3 side there. What did I factor out? Must factor out a plus 2, because 2 times is 6. Must have factored the positive. Right? So must have factored a positive 2. And if you check it, the positive 2 and the 3 is positive 6. And positive 2 times negative 4r is negative 8r. So that's to know factorize properly. And then now the 3 minus 4r is a common factor. And so what's going in one bracket is p plus 2. The first bracket, so it becomes p plus 2. And the second bracket will have 3 minus 4r. And that's it. Guys, you just need to practice it. That's the first type, factorization by grouping, or factorization by parts. That's the first type. All right. The second type is just a normal common factor like we get in primary. Yes? Okay,
Yeah, I
Stan?
was asking, yes, sir. I was asking why I couldn't put negative 4PR first.
Why I couldn't put the
Negative
which line?
4PR.
In this
Sir,
line?
when you're changing it.
That line?
Yes, sir. When you're changing it, you could
Yeah,
put
no. So I'm
negative
asking, I put
4PR
that this
first.
line
Yes, sir. Put it first and then put the
in the
negative
front.
AR.
All right, let's do that way. Let's do it. Yeah, you can. Let's do that and see. All right. So let's do it that way and show what will happen. Let's use a different color. So if I'm doing 3p minus 8r minus 4pr plus 6, let's go. We're gonna say that the same two factors, not necessarily in the same order, but we're gonna same two factors. You're saying put negative 4p in front, right?
Yes,
And then
sir.
put 3, don't it? Right?
No, sir. I was saying
Agreed?
you'd leave the AR.
Huh?
Oh,
Leave the 8r.
yes, sir. That's what I was saying. If you could leave the AR there.
Oh, you want these two together?
Yes. No.
Yeah, man. All right, no problem.
Yeah.
It's not one way with it, no problem. So you're saying, I mean, you can rearrange it a million different ways, but the values must be in a friendly order. All right. So you're saying put negative 4pr and minus 8r. So your common factor first is gonna be the r. That's what you're saying. That's all. So you want your common factor first to r then, basically. Right? That's what you're saying, right? Now, if you do it that way, they have these two values to put down. This one. So in that case, you'd have to put plus 3p plus 6. That's what you have to put. Plus 3p plus 6. Why do I have to put plus 3 plus 6? Because in this, the p comes with in front. P, so the p coming, since the p comes in front of those two, p must come in front of those two. And this can work as well, because then my highest common factor, my highest common factor in these two terms would be negative 4r. A factor at negative 4r, I will get p minus 2. P plus 2, or p plus 2. If I factorize negative 4r, I will get p plus 2. You can check it in because this times this but that, and this times negative 8r. Then I will put back the p plus 2 in the second bracket over here first. And if I put a p there, I'm going to factor the positive 3 outside here. The p inside must have factored the positive 3. So factor out a positive 3. All right. And then what would happen now? My first bracket will be this. So my first bracket will have negative 4r plus 3. My second bracket of p plus 2. Essentially the same two brackets I have now. Because say p plus 2 here, plus 2. And this is 3 minus 4r is minus 3 minus 4r. Same thing. Minus 4r plus 3, same as 3 minus 4r. So essentially it's the same thing I have. Alright, so I can write this as 3 minus 4. So instead of minus 4r plus 3, I can write 3 minus 4r plus 2. So it's the same factors I get. Plus 2, p plus 2. P minus 4r, p minus 4r. So it don't matter where you start, you're going to end up with the same two factors if you do it correctly. All right?
Yes,
Once
sir.
you rearrange them and set them out in a friendly order, you will get the same two factors in the end.
Yes, sir.
All right? So that was a good question. Yeah, good question. That. All right. So you see, you have to do it the way all your eyes see it first, whichever value you want to use as your common factor first. But you have to just make sure you set out the values in a friendly order so that they are consistent. You want the values that are so that they are consistent. All right. So type 2, back to type 2 now. By type 2 is the one you just have a simple common factor question to do. Simple common factor. So the simple normal primary school common factor. There's a common factor in the value. And you have to use the highest common factor, not just a common factor. You always use the highest common factor. For example, now 2m squared 6m. The highest common factor is 2m. So you factorize 2 out of this, you left with m. You factorize 2m out of that, you left with plus 3. And that is the answer. 2m plus 3, and then inside you can't factorize more, so you're done. Once you can't factorize any more, it's left in the bracket, you finish. Always check if what is in the bracket can be factorized any further. Because the question will always say factorize completely. So you have to factorize so that there's no factorization that is possible again when you're finished. All right, the second one is 50x squared y minus 20x y squared. So you're looking for your highest common factor. Now, in terms of the numbers, the highest common factor is a 5. In terms of the x terms, you have x squared, you have x, and so the highest common factor x. In terms of the y, you have y and y squared. The highest common factor of y squared is y. Is y. The factor out of 5xy. So you already know. You divide 15 by the 5, you get 3. You divide x squared by the x, you get x. And you divide y by the y, 1. So the y factor already. Alright, that's that. And then now on the other side, divide the negative 20 by the 5, negative 4. You get negative 4. You divide the x already. So they're gone. And divide the y squared by y. And that's it. Common factor. That cannot be factorized any further. That's it. 5xy into 3x minus 4y. That's it. Can't factorize any further. That's a common factor. All right. The next one that I like set now is the difference of two squares. So here the next one, difference of two squares. Difference of two squares. And there's a rule for the difference of two squares. And the rule is this. I don't think I have it on here, but the rule is that, for example, a squared minus b squared is equal to a minus b times a plus b. This is the rule. When you get the difference of two perfect squares, the difference of the numbers multiplied by the sum of the numbers. A minus b times a plus b. And you don't put by the square. That's a rule. All right, so that's when you have a difference of two perfect squares. So let's look at these examples now. All right, the first example is 9m squared minus 4. So this is a perfect squared number, and that's a perfect squared number. All right, so person will say, oh, the math factorize and there's no common factor. It's because the difference of two squares is not the common factor method. Is now. There's no common factor there, but you have the difference of two squares. So what you do first, you write them as the difference of two squares. So you write one as 3m all squared minus, and I write 4 as 2 squared. And they apply the rule for the difference of two squares. Become the difference of the numbers is 3m minus 2 times sum of the numbers, which is 3m plus 2. And you're done. That's it. All right. For the second one, we have 1 minus 4k squared. Now, 1 give people a problem all the time because people fail to remember that 1 is actually a first perfect square. 1 is the same as 1 squared. And 1 give people problems all the time. We have to ensure that we remember that 1 is a perfect square. So this actually is the same as 1 squared minus 2k all squared. 1 is the same as 1 squared. So that actually is the difference of two squares. We have to remember that 1 is a perfect square, especially when we're doing a factorization question. We have to remember that 1 is the same as 1 squared. 1 is a perfect square. So the perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, and so on. You have to remember those numbers, 81, and so you have to know those numbers, the perfect square numbers, all the way up to, I think, about 15 squared, which is, I think, is 225. You have to know all of the perfect square number. 14 squared is 196. 13 squared is 169. You have to know those perfect square numbers. All right? See if you can know all the perfect square number up to 20. Learn all of them. Easier, just know them. All the perfect squares up to 20. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9, 10 squared, 11 squared, 12 squared, 13, 14, 15, 16, 17, 18, 19, 20. Learn all of them. Make sure you know all of them. Those perfect square numbers up to 20 for your CSEC, and you'll be good. All right? So these now become 1 minus 2k times 1 plus 2k done. That's it. Difference of two squares. All right, simple as that. We have to remember that 1 is a first perfect square. All right, and then now the other type of factorization that we can get a combination when they kind of combine them. So when they can, the most they like to combine the common factor and the difference of two squares. Right, but sometimes they do combination with the factorization by parts as well. So they like to combine them. But most times they combine the type 2 and the type 3. Combine them. All right. All right. So let's look at an example of when they combine them. Let's look at this one. All right. So we have 3 minus 12a squared to factorize. 3 minus 12a squared to factorize. Now, firstly, all we have is a common factor because 3 is not a perfect square and 12 is not a perfect square. So initially, all we have is a common factor, which is 3. So you factorize out the 3. You factorize over 3, 1 minus 4a squared. And then what you have inside bracket was the difference of 2 squares, and you have to see it. If you don't see that, that's the difference of 2 squares. You're going to lose marks in the exam. If you just leave this as the answer, you're going to lose marks. Because the question will say factorize completely. Meaning you have to factorize it till you can't factorize any further. And this can be factorized more because the bracket has a difference of 2 squares in it. So this becomes 3. Don't throw out first factor. No. That's another mistake people make. They're so now focused on this that they forget 3 and leave out the 3. This is a first factor, so you cannot throw it away. And you're going to write what's inside, as a difference 2 squares. And so it becomes 1 squared minus 2ar squared inside big bracket. The 4a squared is the same as 2ar squared. And then you apply the difference now of 2 squares. So it becomes 3 is the first factor. And that's what is in the bracket. Becomes 1 minus 2a times 1 plus 2a. That's it. That's it. All right? And then if we look at the next example, I want to go and practice all these questions by yourself, guys. The next example is 50xy squared minus 18x to factorize completely. Firstly, the common factor is 2x. That's it, The common factor first is just 2x. So if we factorize it, 2x becomes equal to 2x bracket. This becomes 25y squared minus 9. This is a perfect squared number, and this is a perfect squared number. So we're going to write is the difference of 2 squares now. So it becomes, throw away the first factor, which is 2x bracket. Inside here, you get 5y all squared minus the 9 is 3 squared. See that? So you actually have the difference of 2 squares in the bracket there. You have to see it. And then you apply the rule for the difference of 2 squares in the bracket and don't throw the 2x. So you get 2x bracket. Apply the rule now. 5y minus 3 is 5y plus 3. And that's it. Factorize completely. That's it. And what's the other type of factorization? Which one is type 5? For them here, which one is type 5? Which one is not listed here? Type 1 is factorization by parts or by grouping. Type 2 is just common factor. Type 3 is difference of 2 squares. Type 4, that I said, is the combination type. We'll combine those. Which type is type 5? Anybody can tell me?
Quadratic.
And the expression.
Quadratics, man. The quadratics that we just did. Yes, the quadratics, one that we just did. The quadratics. We did that a while ago, where we have to split the middle term. Type 5 is the quadratics. All right. So those are your thing. But before we close, we're gonna do a look at one example now from homework. We'll do the first one. The homework now are those questions. Homework number 2 in the handout. Homework number 2. All right. So homework number 2 is the next homework that you're supposed to do. Let's look at it. Homework number 2. Let's put it on this side. Homework number 2. All right. So that homework number 2 down, guys. All right. So that's the first one. That's a factorization. Most of it is factorization. They have these questions to do. Homework number 2. And you see, that's an equation, like a simple equation to solve. All right, that's something about quadratic. All right, to factorize that quadratic right there. Common factor. That to factorize common factor. That's a difference of 2 squares. This is a quadratic under here, and a common factor up there to solve. There's fraction to do. So now we'll do these simple topics, even though it's not going to do that. Take the opportunity and do those. This one is to factorize these and to expand that. All right, that's homework number 2. Let me see if they're on the next page. All right, somewhere on this page. All right, so there's an equation to solve right there. All right. Then we have these to do factorize. So most of these are factorized. All right. Factorize. That's it. Then we have that one to solve. And then we have this. By the way, this also is a question that is also do. So the first question in homework number 3 should be on homework number 1. Now let me tell you something before we proceed. You see, when it's a quadratic equation, that's a quadratic equation, basic. And I tell you to solve it, and there's something like this, give you answer correct 2 decimal places. That is because you cannot solve this by factorizing. You have to use the quadratic form to solve it. So generally speaking, when you see them telling you how you must give your answer in a quadratic equation, because the values are not exact, you have to use the quadratic formula for that one. All right, so yeah, in the classwork on Wednesday, you're gonna have to do everything that we did today: quadratic formula, factorization, factorization of all the types. You also have to do a quadratic formula question. All right, for the classwork. Remember, tomorrow we're gonna be able to send some questions in this one tomorrow.
So do this for tomorrow, sir. This must be done before for tomorrow.
Yeah, man, do some of the questions. I don't have to do all of them. Just try and do as many of them as I can. In tomorrow's class, homework number 2. Tomorrow's class, we'll go through some of them and to some more the factorization tomorrow.
Yes, sir.
All right, let us just do this question before class, right? Let's just do this first one before we end the class. All right, so let me set it up. Let us just do this one. We've called it a day. So we're gonna factorize these. Hold on, yeah, let's factorize these. And then what I might do is just solve the third one, put that an equation and solve, right? The third one. All right, let me change something. Escape. All right, let me make a little change on this. Wait. So at this third one, I'm not gonna factorize. We're gonna actually solve this. Put this equal 0. I'm gonna solve it, right? I want to solve it both ways using the formula and also so let's do this before we finish the class today. All right. Okay. So let's go for whiteboard and let's do this thing. All right, yeah, so let's just run through these quickly. So first 2 we're gonna factorize, the third one we're gonna solve. All right, so part 1 is to factorize 2ax plus 3ay minus 2bx minus 3by. And you do a look check. It's a factorization by parts because we see 4 values there, 4 terms. All right, so look at the first 2 terms. The common factor will be a. What would that mean? That would have an x value followed by a y value. So over here, what you want is to have x value by a y as well, which is the case. So because you have that, it means that you don't need to rearrange everything, anything. Everything is set out for you nice and easy already. All right, and so you can proceed. So the highest common factor in the first two terms is a. So you factorize the a. You factorize a, you're gonna get 2x plus 3y. You must have the same 2x plus 3y in the bracket over here. Two brackets must have the same thing. And then you look at this. If the 2x factored inside here, then the minus b must have factored out the minus b. You must factor out minus something or plus something. All right? So that's why I know what is to factor out. Minus b must have factored out. All right? Factor out the minus b and check it. Minus b times this give that, you know? And then check the other one in particular. Minus b times this give me minus 3 the b and the y. Minus 3by. So you know that is correct. Because if you multiply those, that's what you're gonna get. Then the 2x 3 become your 2 plus 3 becomes the common factor. And it is a minus b will be factor in the first bracket. So because a minus b times 2x plus 3y. And that is the answer for that one. Done, nice and easy. Part 2. Part 2 is for us to factorize 5x squared minus 20. I see two terms and I see the minus sign. So my brain thinking about the difference of two squares, but that's a perfect square and that's a perfect square. So initially it's just a common factor. Common factor. So the common factor, factor 5, let's put it under it. So it's equal to factor 5. When I factor 5, I get x squared minus 4. This divided by 5, 4. And then now you can't stop there because right here now you have the difference of 2 squared because the 4 is the same as 2 squared. And so it becomes 5 bracket x minus x squared minus 2 squared in the bracket there. So I've written the 4 as 2 squared. And now you have the difference of 2 squared. And so it becomes 5 bracket x minus 2 times x plus 2. And basically that is it. Factorize it completely now. That's that. All right. Now part 3. Another part 3 always for good measure. Let's do part 3 by factorizing. And also let's do it by the quadratic formula. All right. So part 3. We are now solving 3x squared plus 4x minus 15 equals 0. Let's practice. All right. Let's practice. So first thing is multiply my a and my c. That is 3 times negative 15. That's 3 times c. 3 times negative 15 is what? Negative 45. I want factor negative 45. That be my middle term of plus 4. 4. All right, so I'm searching for factors of negative 45 that add to positive 4. If I can't see what those two factors are off the bat, right off the bat, you go down the list of factors until you find it. All right, since I want factors of a negative number, see this is a negative number, one factor will be positive and one factor will be negative. Give the larger factor sign of what this is, so the larger factor is going to be positive. All right, so that the first two factors are 45, 1 and 45. Give the large one the positive sign, the small one the negative sign. But 45 minus 1 is 44. You don't want 44, you're searching for 4. So the next two factors are 45 are 2 and what? 2 and nothing. 3 and what? 3 and 15. 3 and 15. Give the larger one plus, small one the minus. But 15 minus 3 is 12. You want 12. You want 4. So that can't work. So you go to the next two factors of 45. The next two factors of 45, you got 4 and what? 4 and nothing. 5 and what? 5 and 9. 5 and 9. If the larger one does, smaller one the minus. And that's it. 9 and minus 5 is 4. So yes, you want 4. See, there's a plus 4 you want, and that's a plus 4. So you're going to split the 4x up here into minus 5x 9x. Or you can put the 9x minus 5x. All right? So found the factors that you want. So this now, this equation now becomes, let's look at it. Put this to the side. All right? The equation now becomes x squared. I'm going to put the plus 9x minus 5x minus 15. Why? Because I want the 9 to go with the 3x. I want 5x to go with the 15. You have to set it in a friendly way for yourself. And this is now equal to 0. And you always check that way you split the middle term into will give you the middle term there. 9x minus 5x. Because if I made a mistake, for example, and put them all the way around, like put as a minus and put this as a plus, this will be equal to minus 4x, but it's a plus 4x may have. So I know that that will be wrong. So you must always check the term, right? So the correct thing that's a plus, that's a minus. Then I'm ready to factorize now. Highest one factor in the first two terms there is 3. So out of this is 3 is x. 3 of this is 3. What do I do? Put back the same thing in the bracket over here, x plus 3. Then I look. If I factorize the x out of this down here, it means that the negative 5 come out here. Negative 5 factor over here. I factor the negative 5. Then I check it. Negative 5 times 3 is negative 15. So I know I factorize it. This now equals 0. Right? Then the x plus 3 becomes a common factor now. X plus 3. And so becomes 3x minus 5 times a common factor. 3x minus 5 times a common factor of x plus 3 equals 0. All right? And remember now is either this bracket equals 0 or this bracket equals 0. So I don't have to write another step. Either that equals 0 or that equals 0. See it here? In the first case, to get the x, I would carry over the 5, make it positive, and then divide by the 3. Right? So the x would be equal to positive 5 over 3. That's the first one. Or for the second one, I would carry over the 3 and it becomes negative 3. So for the second one, the x will be equal to negative 3. And then I can erase it to equal 0 here. And that's it. But understand that? That's it. All right, let's do the same question using the formula. Just for practice before we close. Let's use the same question. So suppose we get the same two answers. 5 over 3 and negative 3. So let's do the same question using the formula now. Same question. So we're doing the same question with the formula. So we have 3x squared plus 3x squared plus 4x minus 15 equals 0. All right. And it is already standard. So all we need now is the A, the B, and the C. All right. So from here, it's a different color. So from here, the A equals 3, the B equals 4, and C equals negative 15. All right. We're going to the quadratic formula now. Let's write out the formula this time. So C equals minus C plus or minus the square root of B squared minus 4AC. All everything divided by 2 times A. Everything over 2A. All right, and they're putting in the values now. So x equals minus b. The b is 4 plus or minus square root b squared, that is 4 squared, minus 4 times the a, which is 3, times the c, which is negative 15, all over 2 times a is 3. All right, you take your time and work out these values now. All right, so you get x equals minus 4 plus or minus the square root of 16. Now this is going to become negative 5 times negative 50. That's what they're going to get. It's going to become a positive, right? 180. So you're going to get a positive 180. That's what this will to be. Negative 2 times negative 15 give you positive 180. All right? Divided by 6, 2, 3, 6. All right? Let's continue. So I get x equals minus 4, so minus the square root of 196. Well, the square root of 196 is actually 14 divided by 6. Right? Let's double check that. 196 is 14. So you're going to do 14 and remove the square root sign. So you get x equals minus 4 plus or minus 14. Square root of 196 is 14 divided by 6. So you're going to get 1 root with the minus and 1 root with the plus. So you're going to get x equals minus 4 plus 14 plus 6, or x equals minus 4 minus 14 over 6. All right, and so x equals minus 4 plus 14 is 10. Same as 14 minus 4 is 10. 10 over 6. Or x equals minus 4 and minus 14 is minus 18 over 6. Minus 18 over 6. Did you know x equals the 10 divided by 2 is 5 and the 6 divided by 2 is 3, or x equals 18 over 6 is 3 and negative 3. See, same two roots, 5 over 3 and negative 3. Let's look back it up here, right there. 5 over 3 and negative 3. Same two answers using the quadratic formula. All right, guys, and that's it for today. Any questions? Anybody have any question that I want to ask?
No, sir.
Anybody
Just
go?
what time is class tomorrow?
But all right. Any question from anybody? Okay. So I guess everybody is fine. You come on to the class, you need to come on with your correct name, please. Who is Zoms Mac? MCK. Who is that? You need to log in with your correct name, please, and thank you, everybody. Those are the rules for the class. I'm gonna send about the rules again. You have to log in with your correct name. All right.
Sir, if DeAndre, sir, what happened was that light
Light
went away, so I borrowed my mother's phone and used the data.
Oh, okay. Okay. Well, remember, you can always change your name, right? So that's for the purpose of the class. Just change the name to your correct name, and then you can always revert to what you had before after the class, please. All right. I want to see the correct names during the class time.
Sir, what time is class
All
tomorrow?
right. So anybody have any question? All right. So the aim is 3 o'clock tomorrow. Right. I know the schedule is for 5, but because school is not yet open, we're aiming for 3.
Yes, sir.
All right. School is not yet open, so if there's gonna be a change, I will send a message to the group so you can know. Hold on, let me stop this record. Let me stop the recording.